This unit is simplifying, proving, and solving trig expressions and equations. In lesson 1, yesterday, we did some simplifying. Today we're going to do some proving. In lesson 3, we're going to do some of both, simplifying and proving. And then, lesson 4, we are going to get into solving and continue that in lesson 5. So that gives you a little overview of where we've gone and where we are today and where we will be in the lessons to come. Alright, so proving. What does it mean to prove an identity? To prove an identity, we want to show that the left side of the equation is equal to the right side. Or the right side is equal to the left side. I mean, it's basically the same thing. Now, there are some tips for helping us do that. First off, first one is to work the more complicated side. Now, this seems kind of counterintuitive. Usually you want to try to find something that's more easily understandable to work with that. The reason we want to work with the more complicated side is that the complicated side gives us more stuff to work with. One of the things that we want when we are trying to do these proofs is to have identities that we can sub in. And when you've got a complicated side, you've got a lot more potential for finding an identity that you can sub in for it. So the second tip is to scan for identities, and when you see a potential identity that you can sub in, then sub it in and see what it looks like afterwards. Of course, when in doubt, as we saw yesterday, sine and cosine it out. Next up, use some of your algebra skills. For instance, one of the algebra skills that we used yesterday was to find and use common denominators. Another one that we used was the keep, change, flip method for turning the division of two fractions into a single fraction. Next one is one that we didn't use yesterday. We used it a lot in different levels of math, and that's factoring. Of course, there are others as well. Now, one of the things that we cannot do, let's get a text box in here. One of the things that we cannot do is to use a strategy that you've used a lot in algebra. You can't do the same thing to both sides. For instance, when we were solving equations in algebra, we might say add 3 to the left side and add 3 to the right side. Usually this was totally fine. Here it's not. Now, the reason it's not is that we are trying to prove that these equal signs are telling the truth. The strategy of do the same thing to both sides happens to work because we know that that equal sign is already telling the truth. But that's what we're trying to prove in situations like today. Since it's what we're trying to prove, we can't assume it in the middle of our proof. That would be circular logic. So we can't do that. One of my tips is going to be that we just take one side of these equations and just work with that the whole time. Don't even touch the other side. We want to prove ultimately that one of these sides is equal to the other side. For instance, let's take this first example. I would argue that this left side is the more complicated side. We've got more terms, it's a fraction. Alright, I'd say it gives us more stuff to work with. Now we could, of course, if we wanted to, start with the right side and work with that the whole time. There's nothing that would stop us from doing that. But I think it's going to be easier if we use this side. So this cosine squared of x. Scan for identities. Is there any identities that we can sub in here? For this cosine squared of x, look back at my identities in lesson 1, which, by the way, these are identities that you should memorize. This cosine squared of an angle is equal to 1 minus the sine squared of an angle right there. So let's sub that in. 1 minus sine squared of the angle. That's over our denominator. Now, some students at this step might want to say, I've got a sine up top, sine on the bottom, cancel, cancel, and go from there. But that's not actually a valid way to simplify. In our algebra, in order to simplify a fraction, to cancel something from the top and bottom, the top and bottom need to be in factored form. This isn't in factored form because it's in subtraction form, and this one's in addition form. Now, factoring is something we can do with this top. This 1 minus sine squared is a difference of squares, which we learn in algebra factors us into 1 minus sine times 1 plus sine. Bottom of the fraction stays the same. Now I see I've got a 1 plus sine of x factor on the top, and then 1 plus sine of x factor on the bottom. A few of you might be saying, well, that bottom doesn't look like it's in factored form. You said earlier it wasn't. Well, then let's factor a 1 out of the bottom. Okay, that would be 1 times 1 plus sine of x. Distributive property, it equals what we started with. So that checks. Cancel out the 1 plus sine of x on top and bottom, and then I've got this divided by 1, which is this. Now what I've done is I've shown that the left side of the equation that we started with is actually 1 minus sine of x, just in different clothing. So I've shown that this equal sign is in fact true. The left side does equal the right side. Now at the end of proofs, sometimes in math books, you'll see the letters QED, which is an abbreviation for the Latin phrase quod erat demonstrandum, which basically means what was to be demonstrated. This is something that we wanted to demonstrate, that this left side equals the right side. We've done it, and therefore we are done with our proof. Second example. I'm going to argue that this left side is the more complicated side, part because you've got cotangents and cosecants instead of sines and cosines like you have over here. So when in doubt, let's sine and cosine it out. Cotangent, reciprocal identity, is cosine over sine. Cosecant is 1 over sine. Now I see a fraction plus a number up top here. I'm going to try to get common denominators here. Common denominator, if we turn that into a fraction, would be 1 times the sine of theta. So our common denominator is CD sine of theta. So I'm going to multiply this fraction by sine of theta on top, sine of theta on the bottom. So let me just put this in a different color. That's the sine of theta times 1 over the sine of theta times 1, which basically just gives me sine of theta over sine of theta. Add these two fractions together. So that's my big fraction bar here. Add these fractions together and you use your common denominator when you're adding fractions, and then we add our numerators. Sine of theta plus cosine of theta. And then the bottom of the fraction is 1 over sine of theta. Now, I have a fraction divided by a fraction. I'm going to use this keep, change, flip concept. So I'm going to keep this first fraction the same, change my dividing into multiplying, and then flip my second fraction. So instead of dividing by 1 over sine theta, I'm going to multiply by sine of theta over 1. Now what do we have? I have two fractions, and I've got a factor of sine of theta on the top and on the bottom. This is in factored form because if we multiply the two fractions together, it'd be this times sine of theta. So factored, simplify out, and I've got sine of theta plus cosine of theta on the top. And I have 1 on the bottom. Well, something divided by 1 equals something that you are dividing with. Sine of theta plus cosine of theta. And that's in fact what the right side of the equation is. And so we've shown that the left side equals the right side. And so we can say that's what was to be demonstrated. Last one. This left side looks like the more complicated side to me, so we're going to work with this side here. So I see a square minus a square. This is again difference of squares, and so we will factor it. This is cosecant minus sine times cosecant plus sine. And then on the bottom, cosecant of x plus the sine of x. So this is in factored form because the denominator is basically that times 1. Cancel, cancel. And I've got cosecant of x minus sine of x divided by 1. Divide by 1, and it's just cosecant of x minus the sine of x. Now, we don't have it looking like the right side just yet. So at this point, I'm going to use tip number 3, sine and cosine it out. That's 1 over sine minus sine of x. I'm going to change it into a fraction, sine of x over 1. Now I'm going to use one of my algebra tips, find common denominators. Common denominator, that's supposed to be a CD, it doesn't look like it, would be the two denominators multiplied together. That would be sine of x times 1. This already has the common denominator. We want to make this one have it. So multiply both sides, or the top and the bottom, that is, by the denominator I need. First one stays the same. Second becomes sine squared of x on top, sine of x on the bottom. Now that we have common denominators, we can subtract our two fractions. 1 minus sine squared of x, all over the sine of x. Now we go to our Pythagorean identities, and 1 minus sine squared of x is the cosine squared of x over the sine of x. Now we need this to be a cosine and cotangent. Now I've got a cosine in it. I've got actually, in a sense, two cosines in it. So I'm going to break that cosine squared apart into cosine times cosine. And I'm going to think of this sine of x as 1 times the sine of x. Next up. Pause just a second. We're almost there. What I'm going to do now is I'm going to point out that we can basically unmultiply two fractions. Alright, if we were to multiply this fraction times this one, we would have the previous step. So it's okay to go the other direction too. Now this cosine of x over 1 is cosine of x. This, according to the reciprocal identities, or the quotient identities is cotangent of x, which is